Okay, so now we're back here. We're going to finish this off. Before we go to the last steps, which would be to make a decision and state the conclusion, this will be our conclusion part right here. You don't have to go through all of this to come up with your value. The calculator will do it for you. If I go to Stat, Test, you're going to be tempted to do a z-test, at least on the TI-84, but that is not what we want. We are doing a one proportion z-test here. Now I've already typed in our p null, the proportion that we claim to be true, or that Mr. Cavell claims is 0.8. He made 32 out of 50. Now I have to make a choice here. Am I looking for the p-value where it is not equal to 0.8, which means it could be higher or lower? Do I want the p-value where we're looking at, is it lower? When is it lower than 0.8, or when is it higher than 0.8? In this case, we want lower because our alternative hypothesis, our alternative is that the true proportion is actually less than 0.8, that he's not as good a shooter as he claims he is. So I go to calculate. Now, so the proportion that less than 0.8, here's your z-score. Wow, that's nice. That's our test statistic right there. They did it for us. Here's the p-value, 0.0023, which is what we got right here. It tells us the sample proportion of 0.64, and it tells us that the number of free throws that he takes in the sample is 50. Can you do this on an actual FRQ without having to go through this whole process? Absolutely, you can do that. Okay, so we're going to be using the calculator. Let's make sure we know how to use it. So we are now up to our last stage here. We're going to make a decision and we're going to state the conclusion. M and S. M and S. Okay. So the last part of this is our p-value right here. The p-value tells us the probability that we get a sample proportion of 0.64 or lower if the true proportion is really 0.8. So if Mr. Cavell is correct, if this is his true proportion of shooting free throws, the probability that he gets 32 out of 50, 64%, is less than 1%, the probability, 0.002. In other words, it is almost impossible for this to happen by random chance. So what that tells us, that is so low, that p-value, since the p-value of 0.0023 is less than our alpha, our significance level of 0.05, we reject H naught. The odds of this happening by chance, if the true proportion is 0.8, is so low. It's close to zero, okay? So in that case, because our p-value is less than alpha, we reject the null hypothesis. And what we say, there is convincing evidence of HA, which I'm going to state. There is convincing evidence that the true proportion of made free throws, all right, let's come back up here. This was the null hypothesis. We reject that. The alternative was that the true proportion is less than 0.8. There's convincing evidence that the true proportion of made free throws is less than 0.8. And that is the end of this problem. Okay, so the last thing, remember on the first page here, I'll pull this back up, we got a confidence interval of plausible values, and we were 95% confident that this interval captured, that it contained the true proportion of Mr. Cavell's free throw shooting. Remember that we said at the end, 0.8, because it's outside of this interval, is not a plausible value. It's unlikely, very unlikely, that this is the true proportion. Now we just ran a significance test that gave us the same answer. That because this p-value was less than our significance level of 0.05, we reject the null hypothesis that the p was 0.8. There is convincing evidence that the true proportion of made free throws is less than 0.8, and that is the end of the notes for 9-2.